Happy Thursday. We're finishing up Power Series. Get the word right. As long as f is infinitely differentiable at C, you can find a Taylor series for it. Centered at C. The Taylor series for f centered at C is the summation n equals 0 to infinity of the nth derivative of f over n factorial times x minus c to the n. It is that term right there that is the a sub n in power series. If we're centering it at 0, it's also referred to as the Maclaurin series. It can be shown that if f of x can be represented by a power series centered at C, then that power series is the Taylor series. In other words, the only power series representation of a function is its Taylor series. It is the finding of this a sub n that is the fun part. Find the Maclaurin series. Cosine of x squared. believe cosine of x has already been derived. That should be, yeah, for all x. So cosine of x squared. All right, we just replace x with x squared. And again, it's going to be for all x. And so that one wasn't too difficult because we already knew the series expansion for cosine. Learn series for x e to the negative 2x. Well, the Maclaurin series for e to the x was also derived. It's the series x to the n over n factorial. Bless you. Valid for all x. That would mean that e to the negative 2x would have that expansion. Negative 1 to the n, 2 to the n over n factorial, x to the n. Well, then x e to the negative 2x. Just be x times that power series. -1 to the n, 2 to the n over n factorial times x to the n plus 1 for all x. Here we just want the first 5 terms of the Maclaurin series for e to the x sine x. Since we want the first 5 terms, we're going to want n equaling 0, 1, 2, 3, and 4. Start with 0. The 0th derivative of a function is just the function itself. If I read 0, that's just 0. First derivative. E to the x sine x plus e to the x cosine x, right? And it's going to make my life a lot easier later on to factor out that e to the x. Evaluated at 1. I'm sorry, not at 1. What am I doing? At 0. Just 1, isn't it? Second derivative. Just 2 e to the x cosine. This over. Evaluate that at 0. Third derivative. Two e to the x times cosine minus sine. Again, evaluated at 0 plus 2. Fourth derivative. Negative 4 e to the x sine x. Then evaluated at 0 is 0. Zero, 1, 2, 2, 0. Let's call this T4. Remember, it's the nth derivative over n factorial times x to the n. It was 2. Zero factorial, by definition, is 1. Right, so we do not have any kind of problems with n equals 0. Two factorial is 2. 3 factorial is 6. That'd be the first 5 terms. Maclaurin series for inverse sine. Now, we could just start taking derivatives. I'm gonna notice a problem real quick. It's not really a problem. It's more of a I'm too lazy. What is the derivative of inverse sine?
If I had to guess, 1 over the square root of 1 minus x squared,
What are you guessing?
because I might have remembered it a bit wrong.
1 over the square root of 1 minus x squared. Then you want to take that derivative. The negative 1/2 x over 1 minus x squared to the 3/2. I'm sorry, not the negative 1/2. It would just be negative x over. Because the 2x is going to drop out with that 1/2. Then you want that derivative. Now you have quotient rule. And for every derivative after that, you're going to have quotient rule. I don't feel like doing quotient rule. I'm going to go a different route. Let's find a power series for 1 over the square root of 1 minus x squared first. Then take its antiderivative. Oh, wait, that's going to leave you the same problem. You're going to have quotient rules eventually. Unless we first look at the function 1 over root 1 minus x. Find that power series and then just replace x with x squared. Now I'm not going to have quotient rule at all. Remember, we want Maclaurin series. Centered at 0. So we're going to evaluate each term at 0. Right then. First derivative, negative 1/2 root 1 minus x. I'm sorry. 1 minus x to the 3/2. Evaluate that at 0. Negative 1/2. Negatives wind up canceling each other out. Negative 1/2 and then the derivative of negative x. It's important. No. We want that derivative now. Be negative 3/2 times that 1/2. Right, so negative 3/4. Right then, 1/1 minus x to the 5/2 times negative 1. Evaluated at 0, 3/4. They do not make me mute you. Third derivative. Oh, they better hope there's not a real emergency. Wind up being and there's a reason why I wrote it as 3 times 5. I could even do that instead. Maybe one more just to solidify the pattern. Let's see, ignoring n equals 0 for now, we're just looking at the derivatives. 1/2 to the first. When n equals 2, 1 times 3/2 squared. When n equals 3, 1 times 3 times 5/2 cubed. When n equals 4, 1 times 3 times 5 times 7/2 to the 4th. We're gonna have a 2 to the n in the denominator, right? What about the numerator?
Double factorial.
Be 2n minus 1 double factorial. That means the general term of our series, the a sub n, is that, right? It's the nth derivative divided by n factorial. Can that be simplified? Give you a spoiler. Now the question is how.
I mean, I wouldn't consider it simpler, but you could split n into 2 double factorials and then cancel out part of one of them with the top.
Yeah, I'd buy that, right? You can do the evens double factorials and all, and then the odds double factorials, just multiply them together. Yeah, I'd buy that. I don't know how it's going to simplify.
I mean, now you're left
With the numerator, yeah, I can see how it would simplify.
yeah, I see it as more complicated though.
It is. There is a simpler way. I would say, and this is why I get paid the big bucks, but they're not really big bucks I'm getting paid. More like mediocre bucks. The reason I'm getting paid and you're not. To the n times n factorial is 2n double factorial. That's a 2 to the n is just 2 times 2 times 2 times 2, right? There's n of them. And then factorial just n times n minus 1 times n minus 2, right? So on and so forth. Can't you just group it that way? Pair a 2 with each term in n factorial. Two n minus 2, 2n minus 4. You then have 2n minus 6, 2n minus 8, right? All the way down to just 2, which is the very definition of 2n double factorial. So when we go to write the summation, would we be able to start it with n equals 0? Remember, for n equals 0, we need it to be 1. Does this work for n equals 0? I'll try it. Plug in n equals 0, what do you get? Hmm?
Look at -1 double factorial.
What's -1 double factorial? It's undefined. Factorial only works on integers greater than 0. Greater than or equal to 0. So we can't start with n equals 0. There are two ways around this. I chose this way. The other way is to just shift the index. Then you'd be able to easily incorporate the 1 into the power series. You just shift the index up by 1. Oh, wait. Never mind. That would require you to do n minus 1, which still wouldn't work. Nope. Okay, so this is the only way you can do it. So we're just going to have that 1 floating around. We're still not done. We need its interval of convergence. So we're going to take a look at that limit. Good news, this is actually an easy limit. Numerators and denominators line up nicely with the double factorials.
Not 2n plus 2.
It should be 2n plus 2. Not going to change the limit, thankfully. Isn't that limit just absolute value of x? We need that to be less than 1. I leave as an exercise to show that the series diverges at both -1 and +1. And so our interval of convergence is absolute value of x less than 1.
So this power series is exactly equal as long as your x is between 1 and -1.
Yes. Right, they're going to give you the exact same values.
And all power series are like this, or
Yes.
there's some that are just approximate.
No. The approximation comes when you don't take it infinite. Right. If you stop at a certain point, let's say we only go up to n equals 100 million, that would be an approximation. If you let the sum go to infinity, then it is exact. And that's where I said this comes in handy with data extrapolation, or when you're trying to fit a curve. You just treat it as a power series, treat it as we call it Taylor polynomial. Right, depending on how accurate you want it to be, that's how you set your degree of the polynomial, which will tell you how far to go. And that'll give you your polygonal approximation. That is covered in a standard numerical analysis course. Doing that. Well, that would mean that the function I really want, the 1 over square root of 1 minus x squared, so I can integrate it, be 1 plus the series, 2n minus 1 double factorial over 2n double factorial times x to the 2n. Again, valid for absolute value of x less than 1. Then the inverse sign would just be the integral of that power series. Well, the antiderivative of 1 is just x. When doing the antiderivative of a sum, you're allowed to just pull the integral into the sum, right? Because integrals are linear, right? The integral of a sum is the sum of the integrals. That's why you're allowed to do that. Since we're integrating, we do not lose a term. Right? Differentiation, you lose a constant, which is why your index typically shifts down by 1. Integrating, you don't. Actually, generally, you gain a term when you integrate. We're just integrating this with respect to x. Well, this piece here is just a constant, isn't it? Now, what is the antiderivative of x to the 2n with respect to x? This is like the most basic antiderivative. I guess the most basic would just be dx. Second most basic. Okay, term by term. Antiderivative of x squared. Antiderivative of x to the 4th. X to the 6th. How are you getting them? So what's the antiderivative of x to the 2n? Just 2n? Right, how'd you get x to the 7th over 7 from x to the 6th? There's your antiderivative. It just looks way more complicated than it really is. Plus a constant. We need to find that constant. But that is easy. What's the inverse sine of 0? What is it? Well, I'm just ignoring the C for it. I'm saying, if I ask, what is the inverse sine of 0? What does it evaluate to? One over? Oh, no, 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 no. This does not mean 1 over sine. This means the inverse sine function. And so in other words, sine of what angle is 0? This makes me double-sided because I literally just did this in my pre-calc. So I just covered inverse trig functions for them. Oh dear, except we don't do 0 degrees, 0 radians. But yes, 0! Now plug x equals 0 into here. 0. 0, right? Times anything is 0, so it's just 0 plus the sum of an infinite number of zeros, which is still just 0. You're left with just C. C is 0. So you can just drop it. And your interval of convergence does not change simply by integrating. And so there is the Maclaurin series for inverse sine of x. Sadly, that does not simplify because of the double factorials. It'd be really nice if I could get rid of that 2n plus 1 somehow. The hardest part of finding a power series should be finding the actual general term. First off, taking the derivatives is just tedious, especially depending on the function. Thankfully, you have technology for that, so you can use CAS to find the derivatives. What it cannot do for you is recognize the pattern. Right. I went up to n equals 4. There is no rule on how far to go. You have to go far enough until you can see the pattern. And you can write out a general formula. That is going to be the hardest part. The rest of it was just algebra. Except for that, which was a little bit of calculus. If you can simplify the function down to a function that you already know the power series of, then that makes your life a lot easier. Like the first two. That means now you just avoid the derivatives and the pattern altogether. I believe in the video I gave a list of common power series expansions. E to the x is up there, sine x, cosine x. I think I even did log x. I think I might have done a couple others. May want to write them down. Maybe put them on that sheet with all your convergence tests. And you have to be careful. If instead the first problem asks for the power series of cosine of x squared centered at 1, I couldn't have done it this way. Because we did the Maclaurin series, which is centered at 0. So I actually would have had to go through and try and derive it. So pay attention to where you're centered at as well. That matters. And never forget the interval of convergence. If I ask for a power series expansion and you do not give me an interval of convergence, you will not get full credit. Find the first 4 non-zero terms of the Maclaurin series for secant x. Notice the difference between this one and the third problem. Third problem just asked for the first 5 terms, right? Here we're being asked for non-zero terms, which means we may have to go out further than n equals 3. What is secant of 0? What is it? Oh, 1. Oh, good. That's non-zero. I'm just going to put like a little 1 in parentheses there to signify that's the first non-zero term. Derivative of secant. I already know what secant of 0 is. What's tangent of 0? Zero. Oh, bummer, that doesn't count. Now we need a second derivative. Derivative of secant tangent. Should be secant times tangent squared plus secant cubed. Evaluate that at 0. What do you get? There's our second non-zero term. Third derivative. Not look right to me, but assuming it is. You have a calculator, take advantage of it. This problem gets very interesting very quickly. I'm just going to go ahead and define a derivative function. Actually, probably didn't need to define f of x. I could have just put down derivative of secant x to the nth power. Oh, well. The advantage of this is now I can just do df 3 comma x. Wait a minute, that's not right. Oh dear. Oh. Saw that. Let's try that again. Now, here's the problem. It's giving it to me in terms of sines and cosines. Like that. I don't like that one bit. No, I guess that's a Mathematica command only. What is it? Simplify. Trig. Nope.
Can you just have it plug in 0?
I can, but that is more work than I want. Because I can't define a function where it evaluates it at a point, not in the calculator. I could do it here. It's df. Will this work if I just do this? Derivative of secant x. Oh, wait, I need the underscore. There we go. And it's a third derivative. That's the form I want. All right, and then I believe I can. Actually, I know I can. Do I just remember it correctly? No, he gets this. Yes. And I can have Mathematica just evaluate it for me too. Right, now here's why you can't define it in your calculator. Because if I were to try and define as a two-variant, right, xn, like I did in the calculator, and then I just put in 0 for x, it's going to first say secant of 0 and then try and find the derivative of that, which is always 0. Because secant of 0 is a constant.
And you can't have like make one function and assign it to plugging 0 into the other function or something.
If you can on the calculator, it's way too complicated. Versus what I could do here. I don't want to use df. df2, let's call it. Because I can just define it that way in Mathematica. And now if I do third derivative at 0, it'll give me 0. And so if you can do it on the calculator, it's going to be a lot more complicated than this. Now the TI Nspire CX2 does have Python. So you can actually open up a Python script and then start coding. Don't know how powerful it's going to be considering it's a calculator. Versus if you have Python on your computer. I'm not sure the difference in capabilities there, but it does come with Python built in. So you could probably do it that way. I'm just not familiar with Python, so I can't. All right, so the third derivative is 5 secant cubed tangent plus secant times tangent cubed, right? And then obviously evaluate it at 0, you get 0. Bummer. We still only have 2. So we have to now go out to the fourth derivative. I'm going to write out what the fourth derivative is. Now, if you evaluate that at 0, you get 5. There's our third non-zero term. We just need one more. Well, going off of the pattern, that means we're going to need to go 2 more derivatives out. Because the pattern holds, the fifth derivative should give us 0. And it does. So there's the fifth derivative. Sixth derivative. If you want to sit there and do this by hand, I am not going to stop you. Got better things than trying to talk sanity into you at that point. If you're really competent with coding, you could also just write a code to do this for you until you get 4 non-zero terms. Just off the top of my head, I'd probably use a while loop with an if command in there. I have a calculate derivative at 0 and then say if it's not 0, then add 1 to my variable. If it is 0, then just leave it and have it keep going until I get up to what I want. There's our 4 non-zero terms. We want T6. And I am not going to bother writing out the ones that are 0. 1 over 0 factorial is 1. Then it was 2, so it was 1 over 2 factorial. X squared. Next one was 4. Five x to the fourth divided by 4 factorial. 4 factorial is 24. Then it was the sixth. 61 x to the sixth divided by 6 factorial. Just 720. questions on Taylor series? So remember, it's over n factorial. So it's the nth derivative evaluated at your center, which in this case is 0, over n factorial times x to the n. Again, because our center is 0, otherwise it'd be x minus c to the n. Right, so 2 factorial is 2, 4 factorial is 24, 6 factorial is 720. Anything else? That means we are out of series. I don't know why I did new document. Just wait for this to finish. Third test is now available. Will be due before the start of class next Thursday. Question 1 is the ass kicker. The rest of them should be very straightforward. I didn't even have to really think on any of these except for the first one. See, full credit must show all of your work, right? So remember, when it says determine whether the series converges, your answer is not simply converges or diverges. You need to explain why. If you guess, let's just say you guess converges and it's correct, and that's all you do, you'll get 1 out of 10. And there are only 2 of them that ask you whether converges or diverges. You're welcome. Although technically, right? Determine the interval of convergence, so I guess 3 of them. Uploaded as a single PDF file. The exception is if you use Mathematica and you want to include the code, that can be a separate file. That's fine. Right, notes, textbook, course materials, any model calculator. You just can't discuss this with anyone, except for me. I said it will be due next Thursday before the start of class. Sadly, the final unit is a very short one, which means as soon as you turn this one in, your 4th test becomes available. So if things go according to plan, I'll finish up geometry of the plane next Thursday, which leaves us with 1 week free to do whatever I feel like. Otherwise, if something happens, I just have the following week to finish up. So geometry of the plane is very short, very simple, very straightforward. Shouldn't give us any problems. It is a prelude to Calc 3. And so if you're not taking Calc 3, you may not care that much about it. If you are taking Calc 3, it's going to be very important. And remember, as always, have fun. Speaking of fun. This quiz can either take you 5 seconds if